Hello, good evening everyone. Myself Anjali Prasad. I'm a PMR student at IIT ISM Dhanbad. Today we are going to start with the week 4 assignment discussion session on numerical methods NOC 23 MA 94 taught by Professor Amir Kumar Nayak and Professor Sanjeev Kumar from IIT Roorkee. So we will just wait for 2-3 minutes so others can join, then we will start with the session. So shall we start with the session? Uh, so here is your first question. Which of the following relation is correct? Okay, so you have to find which of this given four relations, which one is correct. So what is mu over here? It is the average difference operator, and this delta is central difference operator. Okay, so you have to find out which of this is correct. Is it mu square minus 1 is equals to 1 by 4 del square, or mu square plus 1 is equals 1 by 4 delta square, or mu square minus 1 is equals minus 1 by 4 delta square, or mu square plus 1 is equals minus 1 by 4 delta square. Okay, so you have to just substitute the values of mu and delta, that is average difference operator and central difference operator, and find out which of these relations is correct. So please proceed and let me know which one is the correct option.
है तो Which of the following relation is correct? Mu square minus 1 is equal to 1 by 4.
Uh,
1 minus.
can you please mute yourself? Miss Sahira Begum. Okay. They are saying C. What others? What about the others? Have you got it as C? You have to expand this average difference operator and central difference operator in terms of shift operator. Try. Are you getting shift operator? That is E. So what are you getting? So correct option is A. You will get it like this. Mu, that is average difference operator. You can write it as mu is equals half of e power half plus e power minus half. That is in terms of shift operator. Okay. Now when you will take mu square, so here it will become square of this term, which will give you, when you will square this term, so you'll get here, this will cancel out, so you will get e, and here you will get e power minus 1, and since 2 times e power half into e power minus half, it will give you 1, so it is simply 2. Now you can write 2 as plus 2 as minus 2 plus 4. Okay, now this can be written as e power half minus e power minus half whole square, right? Plus when you multiply this 1 by 4 with 4, you will get plus 1, right? Now what is this? This represents our average operator, delta. Since in the option you have been given mu, relation between mu and delta, so you have to try to reduce this in terms of delta. Okay, so e power half minus e power minus half, this is simply our central difference operator. Okay, that is delta. So delta square. So you'll get 1 by 4 delta square plus 1. So option A is correct. You will take plus 1 on this LHS. So you will get mu square minus 1 is equals 1 by 4 delta square. Is it clear? You just have to convert the average operator, average difference operator, and this central difference operator in terms of shift operator, and try to solve, simplify it. See, are you getting it, A? If you have any doubt, tell me. Try to get the relation A. The solution is on the screen. Is there any doubt? I hope it's clear to everyone. Shall we move to the next question? Okay. So question number 2 is the value of del power n times del power n of alpha into e power mx is, so you have to find the value of this term. So whether it is alpha times e power mh whole to the power n into e power mx, or alpha into e power mh minus 1 whole to the power n into e power mx, or alpha into mh e power n into e power mx, or alpha into alpha e power mh whole to the power n into e power mx. So find the value of this term. Which one of you this is getting? Just first, for the hint, I'll tell that first apply the del operator on this alpha into e power mx. What you are getting? First, just apply del, that is forward difference operator on alpha into e power mx, and then you can find del square. That is again you have to apply the forward difference operator, and then you can generalize it for nth term. Try, what are you getting? Are you all getting it as B? One of you have said as option B. So yes, correct answer is B. How will get? First, just apply forward difference operator on this term alpha into e power mx. Okay. So what you'll get at x, you will get x plus h, right? Alpha into e power mx plus h minus alpha into e power mx. This will give you forward difference operator is equals. Now you can take this h common, as it is constant, so you can take it outside. So you'll get alpha times e power mh minus 1, and you can take e power mx common outside. Okay, so you will get this after the first, after you apply the forward difference operator once. Now again apply the forward difference operator on this term alpha into e power mx. So you will get del square alpha into e power mx. Now you have to apply delta on, since this is del square means del of del. So this is what you get up of del. So del on this term, del of alpha times e power mh minus 1 into e power mx. Now these are the constant terms, so you just simply take it outside. Uh, Now delta will apply on x. So you will get it as, again, as you have calculated delta of alpha into e power mx already, just substitute that value over here. So you will get alpha into e power mx minus 1 whole square into e power mx. Okay. Now you can see the pattern. For delta you got this, for del square you got this. Now similarly when you will proceed for del n of alpha into e power mx, you will get alpha into e power mh minus 1. Here it was 1, here the power was 2. So for general term you will get power here as n into e power mx. Fine. So correct option is B. Are you all getting it? Finally for delta n of alpha e power mx, you will get alpha into e power mh minus 1 whole power n into e power mx. I hope it's clear to everyone. Try to solve it. Simplify it. Are you getting it? If you have doubt, tell me. Is it clear to everyone? Or is there any doubt? Shall we move to the next question? Okay. So next question is question number 3. You have to find out which of the following relation is correct. Okay. So this represents the forward difference operator and this represents backward difference operator. Okay. Delta plus nebula equals delta into nebula, or delta plus delta nebula equals delta by nebula minus nebula by delta, or delta plus nebula is equals delta by nebula plus delta nebula by delta, or this one. So solve it and tell me which option is correct, which relation is correct. For solving this, you can again use the shift operator. Just apply the values of shift operator at place of forward difference operator and backward difference operator. So which one you are getting? I hope you are solving it. Just apply the shift operator and you'll get, apply the shift operator and simplify it. What are you getting? Let me discuss. Which option are you getting? So the correct option is B. You can proceed as like this. Okay, correct. The correct option is B. Now you can see how it's solved. So you have to basically find as the value of delta plus nebula. Okay. Now this is forward difference operator. So you can write in terms of shift operator as E minus 1. plus the nebula, that is the backward difference operator, you can write it as 1 minus E inverse. Okay, so when you add it, you will get E minus E inverse. Now keep it as it is and multiply and divide by this term E plus E inverse minus 2. Okay, just to simplify this, because you have to get in some of these terms, so you have to do some adjustments. Now just add and subtract 1 in the first bracket, so you will get E minus 1 plus 1 minus E inverse into, now here also you can write minus 2 as minus 1 and minus 1, so you will get E minus 1 minus of 1 minus E inverse, right? Similarly below you can write it like this, 1 minus E inverse times E minus 1. Now when you see here E minus 1 plus this term, right? Now here E minus 1 minus the same term, so you can apply that formula A plus B times A minus B, so you'll get it as A square minus B square, so you'll get E minus 1 whole square minus 1 minus E inverse whole square upon this term. Now separate the denominators and simplify it, so you'll get E minus 1 by 1 minus E inverse minus 1 minus E inverse by E minus 1. Now what is E minus 1? That is our delta, that is forward difference operator, and 1 minus E inverse is nebula, that is backward difference operator. Similarly here minus nebula by delta. Okay, so the correct option is B. Okay, so see to the solution. If you have any doubt in any of the steps, let me know. Yeah, you can find RHS also. Any way you from any side you can do, but in terms of RHS you will have to solve each options, right? You have to check A, B, C, D, all the options. You can go either way. Which one is preferable to you? You can either solve some part of LHS and some part of RHS and equate in whichever step you will get equal, then you can solve it like that also. Whichever you find it easy, you proceed like that. Okay, one of the ways I have shown. Third step. So in the third step, we have simply multiplied and divided by E plus E inverse minus 2. And why we have taken this? So just for the simplification, we have to take this. Okay. And then in the first bracket, we have added and subtracted 1. And here we have expanded 2 minus 2. And here when you will multiply this brackets, you will get this term, E plus E inverse minus 2. Is it clear now? Okay, fine. Any other doubt? Okay, so let's move to the next question. So question number 4 says that find the missing term in the following table. You have been given table with x values as 40, 100, 150, 200 and 250. Corresponding to those x values, you have been given the y value, that is the function at value of function at x. So at 40 the value of y is 4.52, at 100 it's 6.78, at 150 it's 9.31, at 200 it's, you have to calculate it, and at 250 it's given 16.54. Okay, so you have to calculate at value 200 of x, what is the value of y? Is it 12.95, 12.75, 12.45 or 12.25? So simply you have to interpolate the value at y. Try to solve it using the difference operators, since you have not been said to use any of the methods. So try to solve it using the difference operators. What you are getting the value at x equals 200. Try to use the difference operators. So anyone, did you get the value of y at x equals 200? Are you getting it as C? Is everyone getting C? Have you tried it with shift operator or any difference operator? So correct option is C. You will get at x equals 200, you will get y as 12.45. Okay. So in the table you have 4 data points. So just um, resemble first point as y naught, that is 4.52. Then second point as y1, that is 6.78. Then y2 is equals 9.31. This is y3 that you have to calculate, and this is y4, that is 16.54. Okay. Now y3 is unknown. So as you have to calculate y3, so you can see here you will need fourth order difference, right? Since it is on the fourth place. So polynomial of degree 3 can be fit to use to this 4 known data points. For polynomial of degree 3, fourth order difference is 0. Okay. So if you will take the polynomial of degree 3, so when you will take the fourth order difference, it will be 0. So just apply del 4 at y naught, you will get it as 0. So what is del in terms of shift operator? That is e minus 1. So it will be simply e minus 1 power 4 of y naught is equals 0. Now just expand it. So you will get e power 4 minus 4 into e power 3 plus 6 into e square minus 4e plus 1 of y naught is equals 0. Now apply this shift operator on y naught. So when you will apply start from this, so when you will multiply y naught with 1, you will get y naught. Then e, that is first shift operator, so you will get, that is y naught plus y of 0 plus 1, that is y1. Okay. Now when you will apply again the shift operator on that, that is you will get e square. So you will get y2, 6y2. Then again apply the shift operator. So you will get the next term y3. Then again apply the shift operator, you will get y4. So the next equation that you are getting is y4 minus 4y3 plus 6y2 minus 4y1 plus y0 equals 0. Now you have to calculate y3. So take it on the LHS, and rest of the terms just shift it on the RHS. So you will get minus 1 by 4 times, as you shifted it on the RHS, you will get minus y0 plus this becomes 4y1 and this becomes minus 6y2 and this becomes minus y4. Now you have all these terms y0, y1, y2 and y4 with you. So just substitute all those values and divide it by 4. So you'll get y3 as 12.45. Okay. So using the difference operators, you can interpolate the value at y3. Is it clear to everyone? If you have doubt in any of the steps, tell me and try to solve using this method. In any of the steps, if you have doubt, tell me. What 2 days points? What do you mean by that? Okay, you are saying that if there are 2 points missing in this y value, right? Yeah, you can say. The question that you are asking, if 2 points are missing, then also you have to proceed in similar way. Take the starting few points and then interpolate, and then take the other points. Like you can start with the starting 4 points, and then you can start with the next 4 points. Okay. Next question is on that only, so you'll understand. Uh, Anyone have to say anything? Anyone raise hand? Is it clear for if 1 point is missing? Okay. Anyone else? Yeah, Kalavati, do you want to say anything? Do you have any doubt? Or is it clear? Okay. So let's move to the next question. So question number 5 is, the given data represents the production of a certain good over the years. Okay, you have been given data of some good over certain years, like in the year 2017 the production was 200 units. In the year 2018 the production was 260 units. In the year 2019 you have to calculate. In the year 2020 the production was 350 units. In the year 2021 the production was 410 units. In the year 2022 you have to calculate how much production was there. So estimate the production for the year 2019 and 2022 from the given data. Okay, so find out what will be the estimated production in these particular years. Okay, the question that you asked, that if 2 points will be missing, then how to calculate it. So this type of questions can be there. Try to solve it. You can proceed in the similar manner as you did for the question number 4. There you had the less number of data points. Yeah, calculate it. Is it B or something else? For the first missing point, you can take the starting 5 points and have a polynomial, and for the next missing data point, you can start from the point 2018 and consider the point value at 2018, 2019, 2020, 21 and 22 and form the polynomial, and again apply the shift operator. Check your answer correctly. Again, since you have the 4 data points, so you can approximate using the polynomial of degree 3, since you have 4 data points. So you can use the polynomial of degree 3. And again, you know that del power 4 at y naught value, it will give it as 0. So apply that as we did in the question number 4. You got the answer? You are saying that correct option is B, but the correct option is C. Okay, so just check your calculations and see, are you getting it option C? Yes, correct option is C. So let's see how it's solved. So since in the given question you have 4 data points at which the production value is given, so we assume f of x as the polynomial of degree 3. Okay, so therefore the fourth order difference of f of x vanishes at del vanishes, that is del power 4 of f of x is equals 0 for all x. Thus e minus 1 in the place of forward difference operator, you can put the shift operator, so you will get e minus 1 power 4 times of f of x is equal to 0. So expand this e minus 1 power 4. So as we did in the previous question, when you'll expand it, so you'll get those terms and in terms of e power 4 and all. So when you'll apply that on f, so for first that is 1 times f of x, you'll get plus 1 f plus f of x. Then when you'll apply once e on f of x, you'll get f of x plus 1. Right? Shift operator means what? You have to take one step forward. So you get 4 times f of x plus 1. Now for the next term, as you will get it as 6e square, that is again apply the shift operator. So you will get, when you will apply the shift operator on f of x plus 1, you will get f of x plus 2, right? One step more forward. Now the next term was minus 4 into e power 3, that is minus 4 of 4 times f of x plus 3, and here you will get f of x plus 4, correct? So this will give you the polynomial, right? Now put any of the values that have been given to you. So for us estimating this, that is, you can see it will take this as y0, y1, y2 and y3. So for y2 you can take this 4 points, x0, x1, x2 and x3, right? So just put x is equals to 2017. Okay, so when you will put over here f of x, you will get f of 2017, right? Now the next term is, when you will apply the shift operator, you will get f of x plus 1, that is the next data point, that is 2018, right? So you will shift to f of 2018. Now f of x plus 2 means the next data point, that is 2019. So 6 into f of 2019. Here f of x plus 3, that is next data point, it is minus 4 into f of 2020, and here the next data point, that is 2021, right? Now as you have to calculate what, the production at 2019, so keep it on the LHS and take rest of the terms on the RHS. Fine. Now just substitute the values of the function, that is for 2017 f of 2017 will be 200. Similarly put all the values and solve it. You will get it as 305. So production value in the year 2019, you will get 305 units. Is it clear to everyone? So this will give you the first missing point. Then you have to calculate the production in the year 2022. For that, if you will take from, you can take any of the 4 points, but as you can see, what, you should take minus 1 by 6 as commonly, that I'm not getting what's your question. Are you talking about this step here? Are you saying that this should be minus 1 by 6? No. Actually, we have rearranged the terms here. So take plus F 2017 on this side. So you'll get minus F 2017. Similarly, minus 4 times F 2018 on this side, you'll get plus 4 into F 2018. You'll take this term, so it will get plus, and this term will get minus. Now on the LHS, you will be remaining with 6 into F of 2019, right? Now that 6 is going to be divided over here. Understood? So it will be 1 by 6, not minus 1 by 6. Is it clear? Now after you have got the production value in the year 2019, for the production value in the year 2022, if you will take 2017, so it will create problem, because in this shift operators you can see you have to get x, then x plus 1, then x plus 2, x plus 3 and x plus 4, right? So if you start here x plus 4, then this will be x plus 3, then this will be x plus 2, then this will be x plus 1 and this will be x value. Okay, so taking 2017 will not benefit you. So start from 2018, right? So we are taking the initial point as 2018, right? So put x equals to 2018. So here you will get f of 2018 plus next point, that is f of x plus 1, that will be 2019. Then the next point, that is x plus 2, that will be 2020, right? The next point x plus 3, that will be 2021. Then next point x plus 4 will be 2022. Understood? Now as you have to calculate the value at 2022, take all the points on the RHS, leaving f of 2022 on the LHS. Okay, now simply substitute the values of production in each year. That is like f of 2018 will be 260, f of 2019 you calculated, right, 305. You can use it over here, use it. Now f of 2020 will be 350. Similarly put f of 2021 as 410. Substitute these values and then you will get f of 2022 as 500. Fine. So in the year 2019 the production value was 305 units, and in the year 2022 you will get the production value as 500 units. Fine. Is it clear? Try to solve it. If you have doubt in any of the steps, you can tell me. And I hope it gives answer to your previous questions, that if two data points will be missing, then how to use the difference operator. Fine. So similarly you can use when three data points will be missing. Is it clear to everyone? Okay, sure. So let's move to the next question. Question number 6. Question number 6 is that the table gives the distance y, denoted by y, in nautical miles of the visible horizon for the given heights x in feet above the earth's surface. Okay, so simply you have been given the distance value of y, in terms of y, and at given heights x. Okay, so you have to calculate the find the value of y when x is equals to 160 feet. So what will be the distance in nautical miles when x will be 160 feet? Okay, so simply you have to interpolate the value at x is equals to 160. Fine. So here you can use any of the methods and find the value of x is equals to 160. Solve it using any of the methods, either by the shift operator method that we have just discussed, or you can use Newton's backward difference operator or forward difference operator. Using any of the methods, calculate the value of x, calculate the value of y at x is equals to 160 feet. Use any of the methods, forward difference operator, forward difference interpolation or backward difference interpolation, and or you can use the shift operator method and find the value of y at x is equals to 160 feet. Is it 13.25 or 13.35 or 13.45 or 13.55? Okay, you don't remember the formula? Okay, let's other try. Others try. I'm just showing the explanation so that it will help others. Okay, you have got it as 13.25. Is everyone getting 13.25? Check your calculations. Don't make mistakes in the approximations while rounding off. So correct option is C, that is 13.45. Okay, so here it's given using the forward difference operator, that is forward difference interpolation method. For that you need to find the table first, right? So just write all the x values that you have been given, that is 100, 150, 200, 250 and 300. Then write the corresponding y values, that is heights. Okay, so sorry, corresponding distances. So at 100 feet the distance is 10.63 nautical miles. Similarly for 150 it's 13.03, for 200 it's 15.04, for 250 it's 16.81, for 300 it's 18.42. Okay, now you have to calculate the forward difference Okay, so for that you simply subtract 13.03 minus 10.63. Okay, so you'll get 2.40. Check, are you getting it? Similarly, for the second value, subtract 13.03 from 15.04. So you'll get 2.01. Similarly, 16.81 minus 15.04, you will get 1.77. Now 18.42 minus 16.81, you will get 1.61, right? Now calculate the second difference, second forward difference, that is del square y. So when you subtract 2.01 minus 2.40, you will get minus 0.39. Similarly, 1.77 minus 2.01, you will get minus 0.24. Similarly, this will give you minus 0.16, right? Now calculate the third forward difference, that is del cube of y. So you get minus 0.24 minus of minus 0.39, that is 0.5915, and minus 0.16 plus 0.24 will give you 0.08, right? Now you have to calculate the, yes, 13.4573, right? So you can approximate it and you'll get 13.45. Now when you'll calculate the fourth difference, then you'll get 0.08 minus 0.15, that will give you minus 0.07, right? So now the table, forward difference table is with you. Now using the forward difference interpolation method, here x naught is what? 150, 150, it should be 100, right? Sorry, it's mistake. X naught is 100 and h is 50, that is difference between the consecutive points. So here difference is 50, h, so h will be 50. And what is x? X means the value at which you have to calculate the value of y. Okay, so x is 160. Fine. Now using these values you can calculate the p. So p is given by x minus x naught by h. So when you calculate it, so you'll get 160 minus 150 by 50, that will give you 0.2. Fine. So in this way you will get the p, value of p, that is x minus x naught by h. Now you have to use this p value in the Newton forward difference interpolation. So y of, we have to calculate y at 160, right? So y at 160 is given by y naught plus p into delta y naught plus p into p minus 1 by 2 del square y naught plus p into p minus 1 into p minus 2 by 3 factorial into del cube y naught plus p into p minus 1 into p minus 2 into p minus 3 by 4 factorial into del 4 y naught. Since we have got the values till del 4, so we have written it till del 4, right? Now if you have the value at which you have to calculate y, that is given x is equals to 160, so simply put it over here. Otherwise you will just leave it as x, so you will get equation, right? You will get one polynomial. But here as you have been given x, so just substitute it. Okay, so you have all the values. Y naught is what? 10.63, and y naught you have, then delta y naught, that is first term over here, that is 2.40. Then del square y naught is this term, minus 0.39. Okay, similarly del cube y naught is this term, 0.15, and del 4 y naught is this term, minus 0.07. Okay, for forward difference interpolation we take the first row. Okay, you have to take the values from the first row. Fine. Now, and p value is also here, that is 0.2. So you have all the values, just substitute it. then you'll get 13.45. I hope it's clear now. The formula is this, Newton's forward difference formula, and using that you can interpolate the value of y at x is equals to 160 degrees. So you'll get it as 13.4 nautical miles. Okay. Solve it. Are you getting it? Everyone, 13.45. Yeah, x naught value is 100. It's printing mistake. Any other doubt? Is it clear? So forward difference formula, we should take first values, but y we have taken in y as second value. We have taken the first values now. See here. For y naught, it's 10.63. Yeah, it should be 10.63. This should be 10.60, not 13.03. Here it's mistake. Y naught should be 10.63. What? Here x naught should be 100 and y naught should be 10.63. There is printing mistake over here. Is it clear now? Okay. Are you getting it? 13.45? Kalavati, can you please unmute yourself and tell me what's your doubt is exactly? I'm unable to get it.
Ma'am, now we should change the y naught value fully, ma'am.
Yeah, yeah. You have to take y naught value as 10.63.
First value is
Yes,
10.53, the second value is 2.40,
Yeah,
and the third value is minus 0.39, and the fourth value is 0.08.
0.15.
0.15. Ah, okay, ma'am.
Huh.
Okay.
yes, madam. No
Yeah,
problem. No problem, madam. Only mistaken the values.
yeah,
13.03.
yeah.
Otherwise,
There, the values on the screen are not correct. Just put it
yes,
as, take it as x naught take it 100 and y naught take it 10.63. Then
Yes.
first value, that is del y naught, you take 12.40, del square
Yes.
as minus 0.39, del cube as 0.15, and del 4 as minus 0.07. Take those
Yes.
values and try, okay? I hope
Okay.
you will get 13.45. Are you getting with those values?
Yes, ma'am.
Okay. Kalavati, are you getting it?
Yes, ma'am.
Okay. So shall we move to the next question? I hope everyone got the answer. Okay. So next question is, using Newton's backward difference interpolation formula from the following table, uh, in the interpolating polynomial is, so using this table you have to find the interpolating polynomial and you have to use Newton's backward difference interpolation formula. Okay. So at x is equals to minus 0.75, the f of x is minus 0.0718. For minus 0.50, it's minus 0.0247. For minus 0.25, it's 0.3349. For 0, it is 1.1010. Okay. The interpolating polynomial is, just check which one you are getting, A, B, C or D. Substitute the values in the Newton's backward difference interpolation formula and be careful while solution, while solving it. You didn't get the answer for the previous question? Where you are stucking? Others try question number 7. And here, okay. So have you here at the point of x naught, take 100. Have you taken it 100? Kalavati, unmute yourself.
Yes, ma'am.
Yeah. Take x naught as 100 and x
Okay,
as
ma'am.
50 and x is equals to 160. Substitute here.
Okay, ma'am.
So you will get 160 minus 100 by 50. That is 60 upon 50, right?
Yes, ma'am.
So you will not get 0.2. Whatever you are getting, write it 60 by 50, 6 by 5, that is.
Wait minute, ma'am.
So what you are getting, P?
1.2.
Okay. Now just put at the place of y naught, substitute 10.63
Yes, ma'am.
and here at the place of P you will write 1.2 into del y naught, that is 2.40.
Yes, ma'am.
So you'll get 1.2 into 2.40, right? Plus
Yes, ma'am.
P into P minus 1 by 2, that is P, what is P? 1.2 into 1.2 minus 1, that is zero point 0.2 by 2 into del square y naught. What is del square y naught? That is minus 0.39
Yes, ma'am.
plus zero point 0.2 into zero point 0.2 sorry, 1.2 into 1.2 minus 1 into 1.2 minus 2.
Yes, ma'am.
divide by 6 and
Minus. Okay, ma'am.
and multiply it by 0.15
Okay.
del cube. Okay. Now one more
Yes,
term will come, p into p minus 1 plus into p minus 2 into p minus 3.
yes, ma'am.
It's not given on the screen. One more term will come na for del 4.
Yes, ma'am.
Okay, so you will get plus 1.2 into 1.2 minus 1 into 1.2 minus 2 into 1.2 minus 3, right?
Yes, ma'am.
Upon 4 factorial into multiply it with minus 0.07.
Minus 0.07. Yes, ma'am.
Okay, that is del 4. Why not? Right?
Yes, ma'am.
Now simplified. See, are you getting it?
Okay, ma'am.
Okay. Okay. Others try to get the polynomial from this table using Newton's backward difference interpolation. So anybody, did you get the polynomial? It's 13.45. 13.4573, I guess. You're getting it 13.37. Just check your calculations. I think you are making the calculation mistakes. Values don't take from here. It's wrong. Okay. Welcome. Or you can try with this also, like if you'll take y naught as 150, sorry, x naught as 150, then y naught as 13.03, then you can take these values also, 2.01, minus 2.04 and 0.08. For forward difference, it's not like that you have to take first row only, you can take second row also. Okay, so with the same values also you can proceed, like x naught you can take 150 and y naught you can take 13.03, and del y naught you can take 2.01, del square y naught you can take minus 0.24, and del cube y naught you can take 0.08. That's given in this slide. Okay, so with these values also you can try. Are you getting 13.45 with these values? Because forward difference means you can take in this way, like you can take first row or second row also. Now, did you get for 7, question number 7? Anyone? Which polynomial is interpolating? So you are getting it as A. Okay, so correct option is A. So as you have to use the backward difference interpolation, right? So here x naught is minus 0.75, x1 is minus 0.50, x2 is minus 0.25, and x3 is 0. Fine. So for backward interpolation, we take xn value, right? The last value. So x3 is 0, and h, that is difference between the consecutive terms, consecutive points, is 0.25, right? So height is 0.25. Therefore, p is what? For this, for backward interpolation, x minus xn by h. So here x minus x3 by h, you will get x upon, since x3 is 0, so you will get x upon 0.25. That will give you 4x, right? Now, we will form the table for the backward interpolation. So, just write the x values and the values of y. Okay. Now, calculate the backward interpolation. So, for, backward difference. So, for backward difference, just take minus 0.0718, the difference between these two terms, minus 0.0718 and minus 0.0247. Okay. Now, difference between minus 0.0247 and 0.3349. So, you will get 0.3596. Similar difference between these 2 points, you will get 0.7661. Fine. Now, differences between these 2 points, you will get 0.3125. Right. Now, 0.7661 minus 0.3596 will get 0.4065. Now, difference between these 2 points, 0.4065 minus 0.3125, you will get 0.0940. Okay. So, as we have been left with only one term, so we will stop here. So, what are the backward difference terms you are getting? So, here you will get nebula Y, this is Y, Y3, that is 1.1010. Then this is nebula Y3, that is 0.7661. This is nebula square Y3, that is 0.4065, and this is nebula cube Y3, that is 0.0940. Okay, so you'll get it Y3. So what is the interpolating equation? Y of x is equals Y3, that is Yn, plus P into nebula Yn, that is P into nebula Y3, since Yn is Y3 over here, plus P into P plus 1 by 2 nebula square Y3, plus P into P plus 1 into P plus 2 by 3 factorial, that is 6 into nebula cube Y3. Fine. Now since x3 is 0 and y3 is 1.1010, okay, so substitute it, and as we have got p as 4x, so substitute 4x, and nebula y3 is this one 0.7661, so substituted over here, so 4x into 0.7661. Fine. Now plus, put the value of p, so you'll get 4x into p plus 1, that is 4x plus 1, divide by 2 into nebula square of y3, that is this one 0.4065. For backward interpolation we take the last row. Okay, now plus here p into p plus 1 into p plus 2 by 6. Just be careful, in Newton's forward difference interpolation it's minus over here, and in backward difference interpolation it's plus. Okay, so be careful with the formula. Now plus 4x into 4x plus 1 into 4x plus 2 upon 6, and nebula cube y3 is this 0.0940. Okay, so simplify it and you'll get this polynomial 1.002 into x cube plus 4.004 x square plus 4.002 x plus 1.101. Okay, so I hope it's clear to everyone. Okay, shall we move to the next question? So question number 8 is, a test is performed on NPN transistor giving the following results. So one test is given and its results have been shown to you. So base current is F of milliampere in milliamperes, that is given by 0, 0.01, 0.02, 0.03 and 0.404, and collector current IC is given in milliamperes, that is 0, and corresponding to 0.01 it's given 1.22, corresponding to 0.02 it's given 0.41, similar 3.53 and 4.64, 4.62. So calculate the value of the collector current for the base current of 0.05 milliamperes. Okay, so if the base current, that is here, if it is given 0.05 milliamperes, then what will be the value of the collector current? So just take this first row as x and second row as y and solve similarly. You have to interpolate the value of y for the x value of 0.05 milliamperes. Okay, so calculate it. You have to interpolate the value of collector current at base current 0.005. So use any of the methods, Newton backward interpolation or forward interpolation, and calculate the value of base current at 0.005 milliamperes. So what's the answer you're getting? So anyone did get the value of the collector correct at base current 0.005? Just apply the Newton forward interpolation formula. So you will get the option as B. The correct option is B, 0.660. Here we are using the forward difference interpolation formula. So the value at which we have to calculate is 0.005. So x is 0.005 and x naught is 0. This is x naught, x1, x2, x3 and x4. Okay. So x naught is 0 and what is h? That is difference between the consecutive terms, that is 0.01 minus 0, that is 0.01. So h is 0.001. Therefore p is what? X minus x naught by h. Okay. So 0.005 minus 0 upon h, that is 0.01. So this will give you 0.5. Fine. Now we will calculate the difference table. For that, arrange the x values and y values. Now the first forward difference operator, that is del y, you will get 1.22 minus 0, that will give you 1.22. Now 2.41 minus 1.22, you will get 1.19. Similarly, subtracting 2.41 from 3.53, you will get 1.12. Then 4.62 minus 3.53, it will give you 1.09. Fine. Now for del square y, 1.19 minus 1.12, 1.22 will give you minus 0.03. Then 1.12 minus 1.19 will give you minus 0.07. Similarly, this will give you minus 0.03. Then del cube y, and similarly you can calculate del 4y. Now since we have got only one term, we will terminate over here. Now apply the forward difference formula. What is that? Y at the given point that we have to find, that is 0.05. So y at 0.05 is equals y naught Yeah, 0.60, it's correct. Now, y at 0.005 is equals y naught plus p into del y naught. So, what is del y naught? What is y naught? That is 0. Del y naught is 1.22. Then, del square y naught is minus 0.03. Del cube y naught is minus 0.04. And del 4 y naught is 0.08. And substitute the values of p. So, you will get 0.608. Okay. I hope it's clear to everyone. Yeah. Shall we move to the next question? Okay. Now question number 9 is find the cubic polynomial which interpolates the following data. So you have been asked to find the cubic polynomial. Data is given x as 0, 1, 2, 3 and the function value at this x points that is given as 1, 2, 1 and 10. Okay. Find the cubic polynomial. Similarly, you can do using the Newton's forward difference formula or backward difference formula. Again, this is interesting because using the data points, you can find the polynomial. So these are the advantages of interpolation. Okay. Calculate it and tell me which polynomial you are getting. can do it similarly using the Newton's forward difference interpolation formula. And simplify it, you will get the cubic polynomial. Here you don't have the x value, so just keep it as it is while calculating p. And x naught is 0. Your difference between the consecutive terms is 1. Okay, so h is 1. So correct option is A. Are you getting it? A. Here arrange the values of x. Yes, correct. You will get the first option as correct answer, that is A, 1 plus 6x minus 7x square plus 2x cube. Okay, so find the forward difference table, and similarly here x naught is 0 and h is 1, so you will get p as x minus x naught by 1, that is x. Now just apply the forward difference interpolation formula. Here f naught is what? 1, and del f naught is 1, del square f naught is minus 2, and del cube f naught is 12. That is first row. So just substitute all the values and simplify it. You will get 1 plus 6x minus 7x square plus 2x cube. Do anyone have doubt? I think it's clear to everyone because it's similar to the previous problems. Shall we move to the next question? Is my voice breaking again? Is it the issue with everyone? My voice is breaking or it's fine? Okay. So let's, you just check your network connection. I think it's problem from your side. So let's move to the next question. Question number 10 is the following tabular values are given for the function f of x. So for x is equals to 1.0, you are given f of x is 2.7183. For 1.5, you have been given 4.48. Then for 2.0, you have been get 7.38. Then for 2.5, you will be getting 12.185. Okay. So you have to estimate the value of f of 2.25 using the Newton's backward difference interpolation. Okay. So just use the Newton's backward difference interpolation and find the value of function at 2.25. It is similar to the previous questions. Just solve it and tell me what you are getting. So what are you getting the value of f of 2.25? Here you have 5 options. Are you all getting it as D? That is 11.1092. Or you are getting 9.5. So when you apply the Newton's backward difference interpolation, so just calculate a backward difference interpolation table as we discussed earlier. So this will be your x3, that is 2.5, and you have to calculate the value at 2.25. So x is equals to 2.25 and h, that is difference between the consecutive terms, is 0.5. So p will be x minus x3 by h, that is minus 0.5. Fine. Now just put the values in the forward difference interpolation formula. So y of 2.25 is y3 plus p into nebula y3 plus p into p plus 1 by 2 into nebula square y3 plus P into P plus 1 into P plus 2 by 6 into nebula cube Y3. Okay. So what will be nebula Y3? This 4.7934. Nebula square Y3 will be 1.8914 and nebula cube Y3 will be 0.7582. So substitute all these values and P, that is minus 0.5, you will get it as 9.5037. Okay. So check, are you getting it as 9.5037? So are you getting it as 9.50? Yes. Okay, so when you will approximate it, you will get it as 9.5037. Okay. So it's simple. So all we have discussed today is the questions based on Newton's backward interpolation and forward difference interpolation and the shift operators. Okay, and the other difference operators. I hope there is no doubt. If you have any doubt regarding the week 4 session, please tell me. Is it clear to everyone? Any doubts? Okay. So thank you for joining the week 4 discussion session and I hope it helped to you. If you have any doubt, tell me or we will just conclude the session. Thank you. Okay, thank you everyone for joining. We will meet for the next session. Thank you. Thank you everyone. Thank you for joining. Okay, thank you everyone. I'm leaving the meeting.